Hello, in this exercise, I'll be solving a simple implementation of the very famous probability function or probability theorem called Bayes theorem. So let's look at the question first. It asks that, and probably you know that one of the common implementation of Bayes theorem is in finding the spam emails. And that's why this particular question is also very common in data science interview. So here the question asks that 40% of all emails are spam. This is a probability that we already have. And then 10% of the spam emails contain the word clearance, while only 0.5% of non-spam emails contain the word clearance. So what is the probability that an email is spam given that it contains a word clearance? So this will be a classic implementation of Bayes theorem. It's a conditional probability problem. So first, see what Bayes theorem states. Bayes theorem states is that given a hypothesis H with probability PH and evidence E with probability PE, the relationship between the probability of the hypothesis before getting the evidence and the probability of the hypothesis after getting the evidence. So let's put the formula actually. So I'm assuming our probability of hypothesis is PH, and what we need to find through Bayes theorem is that PH given E, that's what we are going to find, and which will be equal to P evidence with H divided by the total probability of the evidence, and this whole thing will be multiplied by probability of the hypothesis. All right, so here what do we have? We need to find the probability. Where we have to find is the probability of that an email is a spam given it contains the word clearance. So this is what we have to find in this problem. So let's just put the formula as it is. So at the top numerator we will have the probability of clearance given it's a spam, and that will be multiplied by the whole thing, which in our case that and the denominator will be the total probability that the word clearance is found, and that would we have to implement the probability addition rule, which will be in this case contains the word clearance given it's a spam mail plus probability that contains the word clearance given it's a non-spam email. Now we already have the formula, then now it's a case of just including the actual numbers. So the numbers at the top will be 0.10%. 10% of spam emails contain the word clearance, so 0.1. Which will be multiplied with the total probability that it's a spam email, and we know that 40% of all emails are spam, so multiplied by 0.4, and denominator will be that probability of clearance which is a spam email, which is 0.1 into 0.4, as 40% of the emails are spam. Just add to it the probability of the word clearance contained in a non-spam email, which is 0.005, into 60% of total emails are non-spam, so 0.6. Perfect. And if we do the calculation, we'll get the value as 0.93. And so our answer is that to the question is that given that what is the probability that an email is spam given it contains a word clearance, that would be 93%. And finally, I just want to quickly go through the additional rule of probability which we used to calculate the denominator in the above fraction. So the additional rule says that first because before finding the addition of the probability rule, we have to first figure out if events A or events B are mutually exclusive. So the rule says when two events A and B are mutually exclusive, the probability that A or B will occur is the sum of the probability of each event. So in that case, that would be P A or B equal to probability of A plus probability of B. And this is the case of mutually exclusive events. And now if two events are mutually non-exclusive, then there is some overlap, so we have to adjust for that. Also in that case, the probability rule says, the probability rule says P A or B. So this is the case when they are non-mutually exclusive. P A plus PB, and then we have to adjust for the occurrence of both of them at the same time, which needs to be deducted. So that would be probability of A and B. So in this case, we used this function. In the above problem, we used this particular rule because an email can be either spam or a non-spam. They both cannot occur together, so they are mutually exclusive. So that's why we used the above function. All right, thank you very much for watching.